Hello. Hello, a very good morning. How are you guys doing? Are you able to listen to me?
Yes, good morning.
Yes, sir.
Yes, sir.
Okay, great. So let me start. I will upload this PowerPoint slide. Oh, okay. Can you see slide?
Yes, sir.
Yes.
Yes, sir.
Okay. So this course is about chemistry of interfaces. Just I am trying to see whether I can use my. Okay. Okay, so this course is about chemistry of interface. So I am Shashank Deep, and I will be taking physical chemistry part of this course. So this course consists of two parts. One is physical chemistry, another is inorganic chemistry. So Professor Kuntal Manna will take over from me after lecture one, and he is also your coordinator and instructor for this course. He will be taking lecture 22 to 42. And here is the detail of contact. Uh, uh, if you want to contact him, you can go to his office. His office is MS720. Phone number is 1510, and here email is given. And he will be taking lecture 22 to 42. So my office number is MS728. Here I see. So if sometime if you happen to be in IIT campus, you can visit me whenever you have any doubt. Phone number is 6596 and email is this. So since most of you are outside, so you can write me on this email address if you have any confusion. Anyway, these things are already given in flyer, which has been sent to you by Professor Kuntal Manna, and he is your coordinator. And so, lot of administrative things you can ask from him. So let's discuss about syllabus a bit. Syllabus consists of two parts, as I told you. First part is your physical chemistry, where we will discuss heterogeneous and homogeneous catalysis, surface chemistry, and kinetics of catalyzed reaction. So although it has been given in only three topics, but I will be taking half of the lecture. And so uh, I will start with kinetics, because I believe that unless you understand kinetics, you will not be able to uh, understand how it is applied to you know uh, catalysis. Okay. The second part, uh, unit processes in organic synthesis, laboratory versus industrial synthesis, natural and synthetic constraint systems for control of reactivity in organic reactions. This all these things will be discussed in inorganic part. The books which we will be referring is these two books Professor Kuntal Manna will be referring to, that is Ernst Lean and Dougherty, Modern Physical Organic Chemistry, and Industrial Catalysis by J. Hagen. What the books which I will be referring is Physical Chemistry by Levine, Chemical Kinetics by Ladler, Chemical Kinetics and Reaction Mechanism.
So you're muted.
Sir, you are moved.
Okay, can you now listen? Am I
Yes.
audible?
Yes, sir.
Okay, so these are the physical chemistry book, one by Levine, another by Ladler, and then Chemical Kinetics and Reaction Mechanism by James Spencer, and then Inorganic Chemistry by this book is written by me, and that is for BTech first year, but at least you can look at thermodynamics and kinetics. Okay, so if you have gone through physical chemistry, you must have come across three different parts of physical chemistry. One is your thermodynamics, and then kinetics, and then quantum. All right. Quantum chemistry. And again, if you go and look at the application quantum, then you come across what is known as spectroscopy. Spectroscopy. Okay. So thermodynamics, kinetics, here we look at the system, all right? Macroscopic property, not microscopic property. Then kinetics talks about rate, and quantum spectroscopy. But before I start discussing kinetics, I will be focusing on kinetics mainly, but in between I will discuss about something related to thermodynamics also. Okay, so let me start with thermodynamics. It is very important to know what is the importance of thermodynamics. So can somebody tell me what is the importance of thermodynamics? Yes? Why a study of thermodynamics is important?
So to analyze heat or energy flow or how work done is done on system.
Energy. Anyone else?
Sir, to study flow of heat.
Study flow of it. Anything else?
So from entropy to Gibbs free energy, everything is learned in thermo. So any kind of reaction would need some knowledge about the thermodynamical quantities. Probably so.
Okay, next one. I'm talking about applications, am I right? So let me ask you, if suppose I know heat flow, what kind of application I can think of?
So we can define the relationship between work, heat, and energy of the reaction.
How it is going to be used in industry?
So it
Or
can
for
be used in processes to extract work.
extract what? Have you studied thermodynamics in BTech first year?
No, sir.
No, sir.
No? Okay, but in 12th class you must have studied, am I right?
Yes, sir.
Yes.
Okay, so thermodynamics, what is the application? Because it is very important to understand application. If you don't understand application of thermodynamics, kinetics, or quantum, you are not going to appreciate, the topic itself. So it is very important to know what is the application of thermodynamics.
Sir, to know whether a reaction is spontaneous or not by calculating the Gibbs free energy and all.
Okay, so suppose in a lab I go. Do I need to know that a reaction is spontaneous or not? I can simply observe it. Why thermodynamics is needed for that? Right? If suppose I see product is forming, then I know the reaction is spontaneous. If I don't see product forming, then I know that this reaction is non-spontaneous.
So, but to optimize the process, we would require thermodynamical knowledge.
Okay, that is one of the important application. Any other application?
Sir, to determine the state of phase and chemical
Okay, so
equilibrium.
let me tell what is the main importance of thermodynamics. You see, it is not about knowing whether a process is spontaneous or non-spontaneous. It is to make a process, what is needed to make a process spontaneous. So we must know how to go from non-spontaneous process to spontaneous. Okay, and the second application is spontaneous to non-spontaneous. How to make a process which is spontaneous to non-spontaneous. How to make a process which is spontaneous to non-spontaneous, and the other way around, if a process is non-spontaneous, how we can make it spontaneous. This is very important application of thermodynamics. Okay, you can take any process. Good thing about thermodynamics, one of the very important application of thermodynamics is, or one of the very important aspect of thermodynamics is, there is only three laws, and that is not. Hello. Okay, can you listen?
Yes.
Yeah.
Yes,
So
sir.
Yes, sir.
yeah. So three laws are there, and apart from three laws, there is a zeroth law of thermodynamics. So, but important ones are first law and second law of thermodynamics, and they are not derived. They are based on the your daily routine, based on intuition. The first law of thermodynamics, that energy can neither be created nor destroyed, and the second, which talks about entropy. So these are the two very important laws of thermodynamics. But beauty of these laws are they can apply to any physical or chemical system. Any physical or chemical system. And the most important application is, if a process is non-spontaneous, how can I make it spontaneous? And if process is spontaneous, how I can make it non-spontaneous. So you are right when you say that for a non-spontaneous process, delta G should be positive. So idea is how, if delta G is positive, how I can make it negative, and if delta G is negative, how I can make it positive. That is the important part of thermodynamics. Now next question is, if delta G is positive and I want to make it negative, what I should do? For that, you need to know how G can be changed. Can be changed. Am I right? How G can be changed. Now, can you tell me how G can be changed?
So temperature.
Temperature, yes.
By changing
Anything else?
temperature.
Yeah, by changing temperature is one way. Second,
Pressure, volume.
pressure.
So
Okay.
entropy.
Entropy कैसे change करोगे बताओ लैब में?
नहीं सर चेंज नहीं कर सकते डेल्टा जी इक्वल टू मतलब एंट्रोपी वाला इक्वेशन.
How I am talking simply, if you go in a lab and you are told, okay, this reaction is non-spontaneous, you need to make it spontaneous, what you can do? So one is temperature, that's right. Second is pressure. Anything else?
Sir, catalyst.
Catalyst doesn't change delta G. Am I right? Does it?
Changing state of material.
Again, changing a state of material, again, you have to play with G. Then, once you are going from liquid to solid or solid to liquid, again there you have to change temperature or pressure to do it. Right? Anything else apart from temperature and pressure? Yes? Can you tell me? No? Have you heard about colligative properties?
Yes, sir.
What we do in colligative properties? What is colligative properties? So G can be changed by? G changed by temperature, pressure, and addition of
inert gases.
non-volatile solute. And that is what you know as colligative properties. Am I right? Addition of non-volatile solute. That is another thing which you can do. For example, if you add colligative, add non-volatile solid, what happens to melting point?
Reduces. It decreases.
And boiling point?
Increases.
So what you are basically doing, for example, you are going from, suppose, solid to liquid. Am I right? Solid to liquid. Something is solid state and you want to convert it to a liquid. Suppose at temperature fixed 25 degrees Celsius. right? If something is in solid form, for example, water is in ice form, what I can do without changing temperature, what I can do so that solid changes to liquid. So these things can be done, right? These things can be done. And that's what the beauty of thermodynamics is, application of thermodynamics is. How I can change, how I can make a spontaneous process non-spontaneous. Let me give you one example. Okay. Have you heard about autoclave? Have you heard about this autoclave?
No, sir.
No, sir.
This is used to sterilize medical equipments. Sterilization, if you go to any pathological lab, any labs which is working on, you know, any lab which is working on like proteins, or they are trying to make proteins, or you want to kill virus, autoclave is one of the way.
So is autoclave is also used while before injecting, cleaning the skin before injecting the injection?
Now, injections, so injections are always autoclave. If
So while cleaning the skin, the area we have to apply the injection.
no, that is not done. Okay, so in autoclave, what you do, you have to heat any material which you want to sterilize at 120 degrees Celsius using water. Okay, so, and you know, at general pressure, atmospheric pressure, what will happen if I heat, suppose, water to 120 degrees Celsius? Will it remain in water form?
No, so it will become in vapor form.
Vapor.
Am I right? You are right that at 100 degrees Celsius, water will start converting to vapor, and temperature will not increase till all water doesn't convert to vapor. And at 120, certainly water is in vapor form. So at 120 degrees, a liquid to vapor is a spontaneous process, and you want to make it non-spontaneous. How will you do it? So you have to apply pressure, and that's where application of thermodynamics comes into picture. So in autoclave, we use pressure to increase the boiling point of water. And that's how you can make a spontaneous process non-spontaneous, and you can use it for sterilizing medical equipments or sterilizing, glass bottles or anything which you are going to use in a lab. So this is one of the applications, right? Let's go to few more applications before I start discussing about kinetics. Okay, have you heard about anytime you have gone for skiing, or you have seen that?
Just seeing that, sir.
You have seen that, okay?
Yeah.
Great. So have you seen their shoes? Huh? Have you seen their shoes?
Yes, sir.
Okay, so what is the shape of their shoes? Have you seen what is behind the shoes?
There are spikes.
Blade. Okay. So there is a blade. Do you know why it has been put?
So that increases the pressure, and so the
Very
ice
nice.
will
Water
Yes,
melts.
increases. Yeah.
Oh, sorry. Ice.
So
Area
this blade.
is
Blade
the
is basically used to increase the pressure. Again, here water to ice. It is a spontaneous process. Water to ice is a spontaneous process. Okay, at that low temperature. I'm not talking about 25 degrees Celsius, but if you go to hilly stations for skiing, then at that temperature, water to ice is a spontaneous process. And you want to convert ice to water. What do? You apply the pressure. Apply pressure. Am I right? Or increase pressure. Apply pressure. What it does? It makes ice to water a spontaneous process. So what happens? Ice converts to water, and that helps you in sliding. That helps you in the sliding. So this is another application of thermodynamics. Now let us discuss one more application. Okay. Now suppose do you know what is the effect of heat if you go to hilly station? What happens to boiling point? What is the boiling point of water? What happens? It will depend on height. But what happens to a boiling point? Is it increases or decreases?
Decreases.
Reduces.
Decreases. Am I right? It will go below 100 degrees Celsius. Means it will change to 80 degree or 70 degrees, something like that. If you go to hilly station, right? And then if you want to cook food, do you think that at 70 degree or 80 degree, the food will be cooked? No, right? But you cannot increase the temperature, or you cannot increase the boiling temperature. Then what we should do?
pressure cooker.
Pressure cooker is one of the way. Yeah. So people use pressure cooker to increase the pressure. All right. So these are the few examples. And now let me, when you cook pasta, suppose at your home, okay, do you know some people uses a pinch of salt? What is effect of that?
Increasing.
So it takes more time to boil.
So again, these are the ways. So I have told temperature effect, pressure effect, and your salt effect. Even like radiators, if you look at the solution, they use non-volatile solute. So you must know how pressure, temperature, and um, your addition of salt affects the delta G value. It has importance. It is not important to know whether a process is spontaneous or non-spontaneous. That you can simply see just by looking at reactant or product. It is important how to make a non-spontaneous process spontaneous, or how to make a spontaneous process non-spontaneous. That is the importance of thermodynamics. Okay, that is the importance of thermodynamics. Now, let me ask you, do you know how we can how delta G changes with temperature?
So logarithm approach.
Temperature dependence of delta G.
When we
So
increase
delta
the
G
temperature,
reduces with
delta
higher
G goes
temperature.
negative.
Delta G reduces with higher temperature. Is it
When
right?
we increase the temperature, delta G goes negative.
But, what? Again, tell me again.
So delta G becomes more negative with increase in temperature. It becomes more spontaneous.
Okay. Anybody else?
The increasing temperature will not make it more spontaneous, but it goes delta G goes negative, much negative.
Okay.
So it depends on the change in entropy.
Change of entropy.
So if the entropy change is positive, then increasing the temperature would make the process more
But
spontaneous. And
again, you have to know how delta S changes. Am I right?
yeah,
But I am simply saying how delta G changes.
So
Delta
relation
S
is logarithmic.
Delta S change. Okay. Let us see. Okay. So let me give you one example. Take suppose water to ice. Ice at 25 degrees Celsius. Am I right? Tell me, is it a spontaneous process? Non-spontaneous.
So at atmospheric pressure or
Yeah, atmospheric pressure.
Non-spontaneous.
Non-spontaneous. Am I right? Okay, good. You want to make it a spontaneous. What you need to do? Let's just think about temperature, because I am talking about temperature dependence.
Decreasing temperature.
Decrease in temperature. Okay. So here delta G is positive. Okay. At 25 degrees Celsius, when I decrease the temperature, it becomes negative. Am I right? To decrease the temperature to below 0 degrees Celsius, it will become a spontaneous process. Okay, water to ice. So delta G going from positive to negative. And take the opposite way. If I think about ice to water, at 25, it is a spontaneous, right? But if I go below 0 degrees Celsius, it becomes ice to water, it becomes non-spontaneous. Okay, good. Now let's take the other process, water to vapor. (25 degrees Celsius), 1 atmosphere. What is delta G?
Positive, sir.
Positive?
Yes.
Now I want to make it negative. What I need to do?
Increase the temperature.
Increase the temperature. This example you already know. Now you see, you cannot say that with decrease in temperature, delta G always decreases. I cannot also say with increase in temperature, delta G always decreases. Am I right? So what determines this?
Entropy, sir.
and
Least Atelier principle. Have you
Entropy.
heard about that?
Yes, sir.
Yes, sir.
हाँ, ली चैटेलियर्स प्रिंसिपल है.
Yes, sir.
Sir.
ओके, क्या बताता है? What it tells? There is something delta H. Delta H is easy to know no, in comparison to delta S. I will let you know one example where you may think that delta S is positive, but it is not positive. Or delta S is negative, it is not negative. Delta H, enthalpy. Exothermic reactions are favored at tell me,
Lower
low temperature or high temperature?
Low temperature.
Low temperature, great. And endothermic?
High temperature.
High temperature.
High temperature. Good. Now can you tell me water to ice, is it endothermic or exothermic?
Exothermic.
Water to vapor?
Endothermic.
Endothermic. So you have to increase the temperature. Exothermic, you have to decrease the temperature. Right? And that again comes from thermodynamics. Do you know the relation between delta G and temperature? Yes. Delta G dependence on temperature?
Minus RT LNQ.
कोई equation का नाम सुना है? Have you heard about any equation which deals with temperature?
Enthalpy
So
minus
with enthalpy,
temperature times entropy.
Have
Minus
you heard about this?
LNQ, LNK.
Have you heard about this?
Yes, sir.
Okay, sign, I'm not sure it is positive, negative, just I can derive, but just keep that thing in mind. This is delta G by T versus 1 by T, and that's what people plot, delta G by T versus 1 by T, and that gives you your dependence of delta G on temperature. Okay, delta G on temperature. And have you heard about this equation? dG is equal to VdP minus SdT.
Yes, sir.
Okay, great. So that tells you about how pressure is dependent. Delta G is dependent on pressure and temperature. And in fact, you can write this equation in this way. This is free energy of reactant or product, but this is your free energy change uh, of process. Okay. Sorry. Delta VMDP minus delta SM. M is molar. In that case, if I am taking molar, I will write here molar. So delta VdP minus delta SdT. This is the equation, right? This is the main equations which tells you about how delta G can change with pressure and temperature. In fact, from this, you can calculate this. Or you can go and get this equation. So this tells you about how delta G changes with temperature. Okay. Now tell me how delta G changes with. In fact, let's go and I show you. It is. For example, let's take solid, liquid, gas. Any compound can exist in solid form, liquid form, and gaseous form, depending on temperature or pressure. Right? So think about this. Let's go and look at the effect of temperature. So dG is equal to VdP minus SdT. So I will write simply SdT at constant pressure. VdP will be 0. Right. So del G by del T at constant P will be given by minus S. So if I plot G versus T, G versus T, okay, let us think about this. S is positive or negative quantity?
Positive.
Entropy is always positive quantity, all right? So minus S is negative. So this quantity is negative. What does that mean? G changes. How G changes with temperature at constant pressure? It will decrease or increase?
Decrease.
It will decrease because this is a negative quantity, so this will decrease. Okay, at 0 degrees Celsius, suppose I am looking at 0 degrees Celsius. Which is the most stable? Solid form, liquid form, gas form?
Solid.
Solid. Okay, so which one will have lower value? Solid, solid, liquid, and gas. Let's take here. So this is at 0 degree. This is for solid, this is for liquid, and this is for gas. This is the free energy value. Now it will decrease, am I right? It will decrease like this with temperature. What about liquid? It will decrease. Now, but let's think about slope. Entropy of liquid is greater than entropy of solid. Am I right? Is it true?
Yes. Yes, sir.
So what does that slope will be steeper for? This one. So this will, just 1 minute. I'll call you later. Okay, so this will go down, and at certain temperature, now liquid has lower free energy than solid. And this temperature is known as, क्या बोलोगे इस temperature? Melting temperature.
Melting.
Right? Similarly, you can have, so ये ऐसे जा रहा है, suppose line. I'm not very good at drawing, so that's okay, I believe. Gas का इससे भी ज़्यादा steeper होगा ना? Because entropy of the gaseous form will be maximum. So there will be a temperature when after that, above that, the gas will become more stable form, and this temperature is known as boiling temperature. This temperature is known as boiling temperature. So this picture gives you idea about how temperature and pressure can be used, to convert one form from another form. And there are cases when, before liquid goes down to solid, liquid becomes more stable than solid, gas becomes more stable than both of them. So what will happen in that case? solid will directly go to gas form. And that process is called
Sublimation.
Sublimation.
So from this graph you can understand this. ये ऐसा हो सकता है इसके पहले ही हो जाए. For some compound ये ऐसे जा रहा है, ये suppose ऐसे जा रहा है, but your gas becomes like this, something like that. All right. So here sublimation temperature is lower than melting temperature. In that case, solid will directly go to gaseous form if this temperature is crossed. And that temperature is known as sublimation temperature. Okay, so this is how temperature affects. Now let's go and see another applications. dG is equal to minus SDT plus VD. You see, these are simple equations which has come from first law of thermodynamics, first and second law of thermodynamics. This is the combined equation. Now I want to look at the pressure effect. dG is equal to VD. dG is equal to VD. So del or the process, if you want to look at the process, then you will write d delta G is delta V dP. Delta V dP. So d delta G by dP is equal to delta V. Right? So delta G changes with pressure will depend on delta V value. Generally, what happens if I go from solid to liquid to gas? All right, what will happen to delta G? V is here positive or negative? Solid to liquid?
Positive. Positive.
And here again delta V is positive and large value. Okay. This is positive generally, but this is negative for what? This is negative for water. You know that? You know that?
Yes, sir.
आइस का वॉल्यूम ज्यादा होता है वाटर से. So this is negative in case of water. So d delta G by delta P is equal to delta V, or dG by del P is delta simply V. Okay. So now tell me how pressure will change for, how free energy will change for pressure with the pressure. If this is positive, let's take positive, exclude this water, and what will happen? If I increase the pressure, G should, ऐसे भी if you take, okay, this is for process I am talking about, but if suppose I am talking about reactant and product, what will happen? In that case, del G by del P is simply V at constant temperature. Yes, this is constant temperature. So volume is positive or negative quantity. ये नेगेटिव हो सकता है. नेगेटिव हो सकता है. Hello?
No, sir.
No. So what does that mean? What happens to free energy when I increase the pressure?
Increases.
It increases. Increases. Okay, so what I will plot is simply G versus temperature only. versus temperature. So solid to this, and let's take here. This is for liquid. Okay, this is for solid. This is for liquid. Okay. Now go back here. G. Let me write here only. Del G by del P at constant T is equal to V. So if I increase pressure, this is suppose at some lower pressure. If I increase the pressure, I expect G to go up. Okay. And the difference will depend on this volume. Okay. So let us think about solid and liquid. Generally क्या होगा? Since volume of solid is lower, so this is the increase at higher pressure will be lower here. And if you take liquid, so I'm taking, you see this difference I'm talking about. This is for solid. So certainly this should be ऐसे difference लो. So ऐसे difference लोगे तो this will be higher. And now take the water case. What happened? I'm not very good at, but if you look at Atkins, this figure is given very well. This is for water, this is for general case. यहाँ पे क्या हुआ तुम्हारा? What happened to melting temperature? It goes down. Here it has increased. So from the graph you can see what is the difference between water and other. Here the difference is smaller, and here if you take difference is larger because of volume of liquid is greater than volume of solid. In this case, volume of solid is greater than volume of liquid. So these things affect, so the way water will behave will be entirely different than other liquids. Why? Because water in solid form has higher volume than water in liquid form, or ice has higher volume than your water in liquid form. Okay, so I will stop here. If you have any questions, just ask. I think time is done. Hello, do you have any questions?
So at constant pressure, the graph which you made between Gibbs energy and temperature, that how did you tell that gases will have higher G than liquid than solid?
I'm talking about 0 degrees Celsius. I didn't talk about because G value will depend on temperature. I told at 0 degrees Celsius, water in solid form or anything in solid form is most stable.
Okay, okay.
And then your liquid and then vapor. But if you change the temperature, the G of solid, liquid or gas will decrease, but the way they decrease will be different for solid, liquid and gaseous form. For gaseous form, the decrease will be steeper because its entropy is highest, and the decrease in G for solid will be least steeper, you can say. Okay, so there
Yes,
will
sir.
be a point when G of liquid will be less than G of solid, and that temperature is known as melting temperature. And there will be a point when G of gas will be lower than G of solid or G of liquid. And that temperature is called boiling temperature. Okay, so a simple equation can give you idea about in what temperature range a compound is going to exist as a liquid form and what temperature range compound is going to exist as gaseous form. And you must remember that every form of a compound or a gas is used for different purpose. For example, liquid nitrogen. Liquid nitrogen has its own uses. Gaseous nitrogen has its own uses. Liquid carbon dioxide has its own uses. Am I right? Do you know use of liquid carbon dioxide? Sorry, solid carbon dioxide?
Dry ice.
Dry ice. And why dry ice is most often used comparison to ice?
It directly converts to solid to gas.
Gas. So it sublimes. Dry ice sublimes. Whereas liquid ice melts. Again, that depends on free energy. Why it melts? One melts, while another sublimes. Totally. In fact, you can explain. So these things are very understood application. Then you will start realizing that what is the scope of thermodynamics and kinetics. Okay, so I have given one picture and then I will discuss again on Wednesday what is the application of thermodynamics. I just wanted to give a in 1-2 lecture what is the importance of thermodynamics, then I will move to kinetics because I am mostly concerned about kinetics. Yeah, in between I will use a bit of thermodynamics also. But when you are studying any course, you need to have a basic understanding of any course on physical chemistry. You need to have basic understanding of thermodynamics and kinetics. Okay, so please feel free to write back to me on email address. Okay, if you have any confusion, and as much as you can interact, you will gain. Okay.
Sir,
Yes.
will the recorded lectures be available on Impartus?
Let me see if I can make it available, but at least I can make a PowerPoint slide available to you. Okay.
Okay, sir. Thank you.
So
Sir, and will you give any preference? Will you give preference,
What?
like which book will you use on which part? Like, कौन से
Okay,
lecture
so
में कौन सा book पढ़ा रहे हो? Like you told 3-4
yeah,
books. So.
that I can tell to you. Right now, you see, Atkins or Levine is the most important book for physical chemistry as such for graduate students. But in between, if I am using any other books, I will let you know. Because this is today's lecture is, you can take from Atkins, but it will be from several different chapters. So it is just a basic introduction to you. So that you can find in the books, but it will be spread throughout the chapters of physical chemistry. So initial lectures will be like that because I am talking about applications. I'm talking about importance or scope of thermodynamics or kinetics. But after that, I will certainly let you know which book you have to follow because mostly I will be following Ladler book, which I have already, given the name of that in the flyer. So Ladler book, initial chapters, you can also go through my book, that can give you in short what is the importance of thermodynamics and kinetics. But then Atkins, Levine's, expansion book, particularly when I will let you know how to use kinetics to know the mechanism of the reaction. So, so for different topics, I will be using different books, and certainly some of the things comes from my own experience in teaching. Okay, so I am teaching this kinetic course from last 5 years to your chemical engineering students. So some of the things comes from my experience also. So it is very important for you to attend all the lectures. Okay, because some of the things you cannot find in a book. Is it okay?
Yes.
Yes. Anyone else?
So please
Nancy?
share the slides later on.
I will share the slide today. Today's slide I will share.
Thank
All
you.
right. So everyday slide I will be sharing on Microsoft Teams. So please go through it. And I think you can download from Microsoft Team videos also. Am I right?
Yes, sir.
Yes.
Sir.
So you can do it. Am I right? If I want to upload, then I have to, edit it also. So I will be sharing slides, and then you can always feel free to talk to me uh, through email at least, because I will take my own time to respond to you, because several times there are a lot of other things going on. But feel free, it is very important to understand basics of physical chemistry, particularly when you are in a chemical engineering course, right? A lot of our research area matches with what people do in chemical engineering. And that's why this course has been designed. This course has been designed through feedback from faculty in chemical engineering department. Okay, so please feel free, and because thermodynamics and kinetics is particularly important for chemical engineers. Maybe I can think of we can think of floating another course on thermodynamics for chemical engineers. Initially, we used to teach thermodynamics in first year course, but now course has been since initially 50% of the course used to be physical chemistry, but now only 33% of the course. So since you have already studied thermodynamics a little bit, and that's why people thought that quantum will be more appropriate. Quantum and kinetics will be more appropriate for first year. But anyway, I will give, like in 1-2 lecture, I will give a summary of thermodynamic, thermodynamic application of thermodynamics, you can say. That if you keep that in mind, you can always go back to books and refer. for if you want to apply in a particular application. Okay. Is it okay? So I will stop now.
Thank you, sir.
Okay, welcome.